Hey, and welcome to this wonderful project that I've kind of designed here called the Candy Dispenser Design Challenge. It's a hands-on STEM and engineering project using the informed design process. In our challenge, you are going to design and build a cardboard candy dispenser that must be hands-free, and we're going to use a distance sensor for that. And we wanted to dispense a serving of candy, or about 8 to 12 pieces. And I'm using candy in the generic sense. I like to use some plastic beads for this project because they don't stick as much. And what we're going to do is it has to be sturdy, safe, and creative. So it's a fun little project to allow your kids to have some fun designing something that is kind of unique and different. And we're going to be using the informed design process. Our informed design process has 8 distinct steps, and you can use these 8 distinct steps in any kind of order. We're going to go 1 through 8, but you can come back and go back and forth as needed throughout the process, and you'll see that during it you might have to cycle around a little bit. But there's 8 specific steps. Clarify the challenge, research it, generate some alternative designs, choose and justify the best solution, develop or build your prototype, test your prototype, redesign, and that's an important step. And then when it's all said and done, we're going to reflect on it and see what we learned. So we do have some specifications and constraints in this project. And specifications are the requirements that our project needs, and the constraints are things that our project is limited to, things that we can only some things we can use and things like that. So our specifications, what's required of this project is it needs to dispense 8 to 12 pieces. Now we're not going to be super specific here. If it dispenses 6 or 7 or 15, that's fine too. We want to use the distance sensor or some other trigger to automate the system, and it has to be repeatable and work over and over again. Our constraints, what we're limited to is we only have a certain number of materials that we're going to use, and we'll get into that here in a minute. And we're going to use the Hummingbird kit to automate our process, and of course, above everything else, it needs to be safe for our classroom use. So the materials, as mentioned previously, are things like cardboard. We like cardboard or corrugated material, and you can use some boxes, and you'll see some examples where we used some pre-made boxes because that just modifies that, makes it a little bit easier. We can use tape. I like masking tape and duct tape for this. Glue, you can use good old-fashioned white glue. You can use hot glue. I like to use hot glue for this. And every once in a while, I'll pull out some brass fasteners that allow us to, or like a screw or a nut and bolt type of thing that allow us to have some pivot points. We are going to be using our Hummingbird kit with the servo and a sensor, and then just your miscellaneous office supplies like paper clips and rubber bands and things like that. Great. So here's some examples of some of the ones my students made. So you can see that we have uh, some hoppers with a servo mounted. We have in the second one there, you have something that rotates. The third one was where a kid went above and beyond the Hummingbird kit and used a remote control for a RC car. And then the far right one is just a prototype that was made. So just some ideas to get your mind thinking about what it is you want to make here. But when you're doing this with your kids and your students, give them some rein to build and explore some different options. Even if you think they're going to fail miserably, the kids will surprise you. Great. So we're going to use, like I said, these knowledge and skill builders that address the steps of our informed design process. And we got 10 of them, right, in this unit, and each one's designed to be about a day. So there's the list of them, and we're going to kind of go through some of those and show you where they fit. So the first KSB is what makes a candy machine work, because I think it's important that our students understand how it operates. So that addresses step one of our process, where we're going to clarify the specifications and constraints. So we're going to clarify our needs. We're going to analyze candy machine and its parts, and that could be a video, that could be having an actual candy machine. We're going to define what our dispenser requires. We're going to identify some potential problems and start to create a labeled sketch of our mechanism. In KSB2, we're going to look and see how our servos operate, because I think it's important that we figure out how those operate before we start mounting them in there. So I think that's kind of an important thing. We get to play with them a little bit. In KSB3, we're going to play with the distance sensor, right? So we're going to incorporate how the distance sensor is used, and then use that to trigger the servo. And then we get into KSB4, and so now we've got candy machine basics, and we got the size, and we understand our servos and what kind of has to happen with those in our stuff, so we can start designing and sketching our candy dispenser object. And we want to sketch at least 3, possibly more. And you could do this individually. You can do this as a group or as a team. And we want a big part here is we want to label the parts. Where's our storage? Where's our release? What's our trigger? How do we deliver it? Where's the delivery mechanism? And we want to explore some different ways to deliver it. So this is addressing step 3 of our informed design process. Then we step over into KSB4, where we got to choose which one we want. So we made all these designs, and this one might be one where we incorporate ideas from different brainstorm session ideas that we did in KSB4. So we're going to choose what we want, and this one might not be our final design. So that's kind of important here. So I'm a little foreshadowing here. This one, we might come back to this step when we test and evaluate, because our plans might not work the way we want, so we have to tweak some things, and that's 100% fine. And once we got the design done and we've talked to the teacher and found out about it, we are going to start building. So now we know where we're going to put our stuff. So now it's just a matter of developing the prototype of it and putting it together. Build the storage, build the structure. How is it going to release? Where, and importantly, where are we mounting our servos and sensors in this one? And then once we get it done, now we can start coding it. Now it's going to come alive with some movement. So now, because we've played with a little bit of coding earlier with this in Bird Brain Snap, and now we're going to wire it up and hide all our wires in our stuff and try it and see and make it work. All right, and then we're going to test it out. We're going to run some trials. We're going to throw some candy in there. Again, I like to use plastic beads because they're reusable. The candy gets a little bit sticky. That candy is a great one for the final part of this, where we have a reflection piece here in step 8. But we want to test it. We want to test it again and again and again and make tweaks. So this is again where we would maybe go back to step 3 or 4, maybe 5, and hit that loop again. So this mini loop inside of our big loop is kind of huge here in doing this. And then KSB9 is where we redesign and improve. So we've tested it. Now we can redesign, and then we might go back to step 3, we might go back to step 4, we might just hop back to step 5. But we're going to go, maybe we need to adjust where our sensor is. Maybe we need to adjust how far away it senses some things. So lots of things in here. Maybe the storage isn't what we want. Lots of things in here to retest and improve. And just iterate. And this is great. This is where we can celebrate some epic failures and some amazing successes here. So make sure you celebrate that. And then finally, we want to communicate or reflect on our idea. So we want to prepare some type of either classroom presentation, a video of some sort, where we are reflecting and showcasing what we did, but also reflecting on what we learned and what skills we did. So what is your role as the facilitator? All right. This is huge. Your role is the coach of this. You are not going to be giving them the answers. Don't give them a step-by-step recipe. You can guide them, you can lead them, but don't give the answers. Encourage the trial and error. All right. Promote some collaboration, and also, maybe you give them some exit tickets where they can promote some questioning processes, and maybe you have to explicitly teach that. But please, at this phase, when we're doing this, please don't just say, we're going to build this, here's a plan, and go build. That's just busy work. So as I've done this, we're going to make mistakes. Issues are going to happen, right? Candy jams, right? Candy's going to get jammed up. It's going to happen. It happens in real life with commercial ones. Try some different mechanisms. Maybe the servo falls off. Let's figure out a different way. Our sensor doesn't work the way we want, right? So there's that. We can adjust some things. And a big one, because we're dealing with middle high school students, we're going to have some teamwork issues where kids don't work. So give them some roles and have them decide on what the roles are at the start of this project. So the assessment of this, what's nice about projects like this is you can have micro conversations along the way to guide some assessment, but you're going to get some feedback on coding there in the early KSBs. They're going to answer some questions. They're gonna how's their design, and there's a rubric involved with this. How does it work, right? How does it work? Does it dispense the candy, right? And then what did they learn, and how did their team work? So there's lots of different little things you can assess in here. But what's nice about these projects, like I said, is the fact that you can have conversations and formative assessment throughout the project where you are talking with them and they're explaining some things. So don't be afraid to question and ask some things and go around and have little, what I call, micro conversations. And then obviously at the end of it, we want to share this demo and demo our dispensers out and have other kids try them and get some feedback, right? So we want to do that. And one of our key takeaways from this is we're experiencing the design process. We're learning a little bit of design. We're learning some coding. We're learning that failure is expected and it's not fatal, and the fact that we're going to have some fun doing it. So please don't think that, okay, everybody's going to be a candy dispenser. That's not what it's about. It's about the process of solving the problem, whether that be this candy dispenser or any other project that you do in class.